Hello everyone, I'd like to welcome you to this video titled Prime Factorization. In this video you will need to take out your math book and turn to page 5, get out your math journal and a pencil. So the goal for today is for you to understand how you can express a composite number as a product of its prime factors. So when we think about prime numbers, it's important to understand that a prime number means only one in itself can go into that number, then a composite number means more than one in itself can go into that number. So that's how you kind of differentiate between prime and composite numbers, and we'll take a look at that as we get into this lesson. So I want you to turn to page 6 of the math book. So you can see it's saying here to write a composite number as a product of its prime factors. So it's important to understand that you can represent a whole number as a product of its factors. So these are not prime factors necessarily, just a product of its factors. Okay, so you can see 18, we take 1 times 18, 2 times 9, 3 times 6. So we can see here the factors of 18 are 1, 2, 3, 6, 9, and 18. So 18 has 6 different factors. So we know it's a composite number because it has more factors than just one in itself. So important to understand a composite number has more than 2 different whole number factors. So that's a key way to remember whether a composite number or a number is composite or prime. Now let's take a look at page 6, moving down into section 2. So it says write a composite number as a product of its prime factors. So it says recall that a prime number has only 2 factors, the number 1 in itself. For example, 3, the only 2 factors are 1 times 3, that will give you 3. Now we're not talking about 1.5 times 2 or anything like that, just 1 times 3 will give you 3 and that's it. So the factors of 3 are 1 and 3. So 3 only has 2 factors, so it's an example of a prime number. So remember, composite number has more than 2 factors. Prime number has only 2 factors, 1 in itself. So 2 and 3 are the only prime numbers in the list of factors of 18. And 2 and 3 are the prime factors of 18, going back to the previous problem right there for section 1. Now there's a question there that says, are 0 and 1 prime, composite, or neither? Okay, you want to think about that as we move into this lesson. And when we think about this question, 0 and 1 are neither prime nor composite. What's the definition of a prime number? Only has 2 factors. 0 and 1 do not have 2 factors. What's composite? More than 2 factors. Neither of them have more than 2 factors, so they would be neither. Now let's take a look at section 3 on page 6. It says you can express a composite number as a product of its prime factors. For example, you can write 18 as a product using only its prime factors. So whenever you're trying to find a composite number as a product of its prime factors, you can only use prime numbers. So we can see 2 times 3 times 3 would be the prime factors of 18. We cannot do 2 times 9 or 6 times 3. Those would be the factors, but not the prime factors. Okay, so we can see the math note here on 6. Finding the prime factorization of a number is not the same as finding the factors of a number. A composite number can be written as a product of different pairs of its factors. So for example, 18 can be written as 3 times 6, but there's only one prime factorization for a given composite number. So there could be multiple ways to write factors of 18, but only one way to write the prime factors of 18. That's 2 times 3 times 3. So you can see moving down to page 7. So now what it's showing you is a way to write a composite number as a product of its prime factors. So for example, what we're seeing here is saying express 60 as a product of its prime factors. So what you can do, you can set it up like this. So you want to take 60, divide it by a prime number, which is 2. Pretty easy. Whenever a number is even, you can always divide it by 2. So we have 30 here, divide it by 2. After you divide 30 by 2, now you have 15, divide 3, 15 divided by 3, and then that gives you 5. So all these numbers here would be prime numbers. So what you would want to do, the prime factors of 60 are 2, 3, and 5. However, when you write a composite number as a product of its prime numbers, you want to list them out. 2 times 2 times 3 times 5. So an easy way to remember or to check that you have the prime factors of a number is that when you multiply all the prime numbers together, you get the original number, which would be 60 there. So this is another way to write a composite number as a product of its prime factors. So what we can do is we can do a factor tree like this. So this is another method. So if you like doing the division like I showed you before, that's fine. But you can see on page 7 of your math book, the method 2 is you take 60 and you think about what can go into 60 or what multiplication problem here can go into 62 times 30. Okay, and then you can see 2 is a prime number. And once you've identified your prime number, something that doesn't show in your book, I always like to circle it so I know that that's a prime number and I don't need to worry about it anymore. So now I'm going to break down the number 30. I can break down the number 30, 2 times 15. Okay, so now I can bring my 2 down over here. So now I have 2 times 2, which is 4, times 15. Still gives me 60 there. So my 2 here is prime. Just bring it down, bring it down. Now I got to break down my number 15. 3 times 5 is 15. So there we go. So we can see prime numbers of 60 are 2, 3, and 5. Composite number as the product of its prime factors is 2 times 2 times 3 times 5. Now you can see we have some dots here. So those dots can represent multiplication. All right, so this would represent the prime factorization of the number 60. Okay, so we're going to go back to the think question. So something to think about here says Sean thinks that a whole number can only be a prime number or a composite number. Explain why you agree or disagree with him. We'll talk about this in class. So this concludes the video on prime factorization. If you have any questions about this concept, please come and see me.